Now, this is a very important statement. It says, in general, metal atoms tend to lose electrons, so they become cations. So we say metals simply become cations because they lose electrons. And non-metal atoms, non-metals, become anions. So that's the trend that you need to remember. And remember, the more you have an understanding of the trends, the better you will remember these concepts. So the chemical formula of a substance is a notation that uses atomic symbols with numerical subscripts to convey the relative proportion of atoms of different elements in the substance. So what does that all say? Well, let's give you an example. Let's say I have aluminum oxide. So aluminum, a little bit out in there, doesn't rust. It actually forms a thin coating of or coat of aluminum oxide, but it still protects it much better than iron from rusting. So what does this notation mean? What this notation, this subscript means, these subscripts, what this simply means is you have 2 aluminum atoms and 3 oxygen atoms. And it tells us that the proportion or the ratio of aluminum to oxygen is 2 to 3. So that's a chemical formula. Much easier to use than just simply writing out the name all the time. And it gives us so much visual information as a symbolic representation. So where are we going? We're going toward naming. We're going toward naming. Now, naming requires lots of practice. We're going to do enough. I'm going to do quite a bit of these in the next few slides, but it's imperative that you do more from your homework. So you must do enough of these. So nomenclature is a fancy word that simply means naming compounds in chemistry, chemical nomenclature. You must memorize all ions in the common ion sheet. Now, used to be that the case, but you will be given the sheet that you can use on the test. But because of the situation we're in, you can just simply use them from the sheet. But you must use it effectively. Now, let's actually look at ionic compounds. We're going to start with ionic compounds. And the ionic compounds on this flow chart right here are divided into binary ionic compounds and ternary ionic compounds. The next one we're going to do is molecular compounds, and acids are all the way at the end. In fact, we may do them in another lecture. But for now, let's look at a cation and an anion, which actually form an ionic compound. The main idea of nomenclature, is right here, is charges must cancel out. Charges must cancel out. So you have to do whatever it takes to cancel out the charges. So by cations, of course, we mean positive. When anions, we mean negative, and that gives you a 0. So notice how the charges cancel out. What does that mean? It means that if I have a positive 2 here, and I have a -1, I can't just leave my answer as a -1. That is not acceptable. So what do I have to do? Well, it means you have to do whatever it takes to make this number equal to make them 0. Now, this is kind of odd. You're like, okay, where did this come from? Well, we're going to use a technique here to name ionic compounds. But like I said, please make sure you practice enough of these in order for you to get them. Doing 1 or 2 problems of these is not enough. I tell you that from now. So you have to do enough of these until you actually get the pattern out of it.